Welcome back to the LINX 3.0 tutorial series. I'm Sam Kristoff from LabVIEW MakerHub, and in this section, we'll learn how to build a LabVIEW application into an executable and deploy it to run as startup so that whenever we power on a BeagleBone Black or Raspberry Pi, it'll start running our code, even without a connection back to the PC. We'll start by opening the project we created in the last section. I'll double-click on my project on the desktop, and we can see I have two devices, the BeagleBone Black and the Raspberry Pi, in my LabVIEW project. My Blink VI is currently under the Raspberry Pi. Before we build it though, we need to check and make sure that everything's set up and ready to run. I'll open the VI, and we'll notice that the digital output is set to 13, but I want it set to 7. I'll update it to 7, but we need to be careful. Front panel controls are only saved in memory and not saved to disk unless we explicitly tell it to. So for example, if I close this VI and open it again, you can see it's reset to 13, its default value. If we built this and deployed it to our BeagleBone Black or Raspberry Pi, it wouldn't do anything because we don't have the LED connected to pin 13, it's connected to pin 7. I'll reset it to 7 and click Edit, Make Current Values Default. This will make all of our front panel controls stay their default values. So now our default value is 7. I'll save the VI and close it. And now if I open it again, we can see that the output channel is 7. Let's go ahead and build this into a startup executable. I'll right click on my build specification and choose New, Real-Time Application. There are a lot of options in here, but we don't need to touch most of them. I'll name the build specification so I can remember what it is later. I'll call it Blinky. Then I'll click Source Files on the left, and from the Project Files section, I'll choose my main VI, blink.vi, and then click the right arrow to put it in the section of Startup VIs. Adding a VI to the Startup VI section tells LabVIEW that we want it to run when LabVIEW starts running on the target after it boots up. It would automatically pull in any dependencies if we had it. So that's all we need to do. I'll click OK, and now you can see I have a Blinky build spec under my build specifications. I'll right click on it and choose Build. Now LabVIEW will build this VI for the Raspberry Pi specifically. This will take just a second and we'll jump ahead to when it's done. Alright, the build completed successfully, so I'll click Done. Now we're ready to run this executable at startup. I'll right click the build specification and choose Run as Startup. This will deploy the executable to the Raspberry Pi and trigger it to run at startup. Now it asks, do we want to restart the Raspberry Pi to start running the VI? I'll choose yes. Now you can see LabVIEW restarted on the Raspberry Pi and the LED starts blinking. Now let's power cycle the Raspberry Pi. I'll unplug power from the wall and plug it back in. The Raspberry Pi will boot up, and as soon as LabVIEW starts, it'll start executing our startup exe. Alright, the Raspberry Pi is rebooted, and you can see that the LED is blinking. If we want to modify our VI and make some changes or control it manually, we can still open the VI under the Raspberry Pi and click Run. The only difference is, this time, since there's already a VI running on the Raspberry Pi, it'll warn us that we're going to overwrite it. I'll say OK, and LabVIEW will deploy our VI and run in interactive mode again. So now we can see our front panel updates. Deploying a startup exe is a great way to deploy your final application after you're done developing all your code and debugging it. In the next videos, we'll learn how to write LINX VIs to access I/O on BeagleBone Black and Raspberry Pi. Make sure to check out LabViewMakerHub.com for more tutorials and projects, and ask any questions you have on the MakerHub forums at LabViewMakerHub.com/forums.